This is how-to video number 2, and in this how-to video we're going to focus on something called Lewis dot diagrams, and kind of the thing that helps me remember the difference between Bohr models and Lewis dot diagrams is this little quote right here. It's what is on the outside that matters. Usually we talk about it's what's on the inside that matters, but in this case Lewis dot diagrams only care about what is on the outside. In this case I'm talking about electrons. We're really talking about those valence electrons to draw our Lewis dot diagrams. And again, to get this information we have to look at the group number up here. 1, 2, 3, 4, 5, 6, 7, and 8. We can't really do anything for Lewis dot diagrams for the transition metals or transition elements. They're a little bit more complicated than the other groups, but we can use 1 through 8 to help us with the elements that are in groups 1 through 8 on the periodic table. So why do we care about valence electrons? Well, I think the most important thing that you'll see is we can use them to predict bonding. That's our next big topic, is the idea of bonding, taking elements, bringing them together, bonding them together to make compounds, and we are going to use the Lewis dot diagrams to help us do that. Just remember, guys, that if an element is in the same or has the same group number means that they have the same valence number, same valence number of electrons. That also means that they have the same reactivity. So same reactivity, meaning that they're gonna react in similar ways when you have chemical reactions and stuff like that. So all of the elements in group 1 right here, hydrogen, lithium, sodium, potassium, all of those are going to behave very similar, and all of the elements in the noble gas column 8 over here are going to act very, very different than the elements in group 1, and it's because of that valence electron, or how many valence electrons they have in that outer energy level. Okay, so that's why these valence electrons are so important, and that's why we care so much about being able to draw Lewis dot diagrams. So again, let's go through this. Step number 1, and this one is quite a bit easier to draw compared to the Bohr model. Okay, so step number 1, we need to figure out, so determine element symbol, and group number. And that's going to come from our handy dandy periodic table, so we'll have to use that. Step number 2 is just to write the symbol. So whatever the element symbol is, you'll write that down first. And then step number 3 is to write valence electrons as dots. That's it. But this step is a little bit more tricky than you would think. So let's pick an element really quick. Well, let's take magnesium. Okay, we'll do a couple different examples. Magnesium is in group 2. So if I would go let's go to a clean sheet. So magnesium element symbol is Mg, magnesium. So that's step number 1 and 2. Okay, I know that it's in group 2. And then step number 3 is to put in our dots to represent the valence electrons. Okay, so this is only showing the electrons in the outermost energy level. It's not showing protons and neutrons. It's not showing how many energy levels it has. It doesn't even tell me how many electrons it has. It only cares about those electrons in the outermost energy level. Okay, now I'm done. That's it. That's the Lewis dot diagram for magnesium. Now, remember, these are electrons. Okay, they have negative charges. Okay, if you remember anything about magnets, okay, opposites attract each other. So opposite ends of a magnet, or opposite poles of a magnet, north and south pole, attract each other. However, if we have two poles that are exactly the same, if they're by each other, they're going to repel each other. Exact same thing happens with these electrons. These electrons don't like to be by each other because they have the same charge. Okay, so that's why I drew them on opposite ends or opposite parts of my Lewis dot diagram. I could do the same thing. I could draw it like this if I wanted to. One on that side, one on that side. But just, you know, they're the furthest away from each other that they can get. All right. If I go back to the periodic table and I take a look at a different element, let's take nitrogen, for example. Nitrogen is in group 5, so it should have 5 valence electrons. Nitrogen is just N. I usually like to start top to bottom. So there's 1, 2, and then I go left to right, 3, 4, and then I just repeat. All right. So there's my 5 valence electrons for nitrogen. And if I would take a look at any other of the elements in that same group, they would have the exact same Lewis dot diagram. Okay, so if you know how to draw one, you know how to draw all of them for that group. Okay, so Lewis dot diagram is not overly complicated. Okay, just need the element symbol. You need to know the number of valence electrons. You put them around the outside. Okay, and you should be good. You should be good to go. If you ever run into let's say a noble gas like argon, argon is going to have a full outer energy level. So they're going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay. And really this is what every single atom wants to have. They want to have 8 valence electrons. We'll talk about that more when we get to bonding. Okay, that's all you need to know about Lewis dot diagrams. Okay, so again, practice, practice, practice.